Our next video is going to be about translations in the plane. So, what is a translation? A translation is a transformation that moves all points of a figure the same distance in the same direction. Where have we seen this? Well, we've been graphing our different types of equations. So, for example, we've graphed absolute value. So to graph absolute value, we knew that we started at 0, 0 for our parent function, and then our slope on each side was 1. So we had y equals x on this side, and y equals negative x on this side. Alright, from here, if we were given another equation, such as y equals 2 times the absolute value of x minus 1 plus 1, we knew that we would have to move this to the right 1 and up 1. So we would come right 1, up 1. Put our point here, and then our slope would be a little different because it would be up 2 over 1. And that would be on both sides. So this would be stretched, and it would be translated right 1 and up 1. So we've been doing this all along. Just now we're going to get back to our vocabulary and say translation instead of moving or shifting. So, when we're looking at translations, we've got to look at a couple of terms. First, we have a preimage. The preimage is the graph of an object before a transformation. So, a lot of times, if we graph something like a shape, we'll have vertices like A, B, and C. So, this is what we will label with our preimage. Now, eventually, we would get to an image, which is the figure that results from a transformation of a geometric figure, and we would label our image with A prime, B prime, C prime. That's how we differentiate between our preimage and our image. We have A, B, and C becomes A prime, B prime, and C prime. To translate a point horizontally by a value of A and vertically by a value of B, the notation may be written one of two ways. We may say a translation of A units right, B units down. Right? That's just saying we might go 2 units to the right or 2 units to the left or 4 units up or 5 units down. Right? It may just be written out for you. Or we might say something, or you might see something like xy becomes x plus a, y plus b. That's saying we're taking our x value and we're going left and right, because our x-axis is horizontal. And then we're taking our y value and we're going up and down because our y value deals with vertical. So let's look at some examples. Let's graph the preimage and image of triangle EFG with vertices E, -7, -1, F, -4, -4, and G, -3, -1, translated 2 units right and 5 units up. So this is given to us, just written out, translated 2 units right and 5 units up. If we want to write this in the other notation, we could say xy becomes, and since we are going left and right with our x value, we will be saying +2, because we are going 2 in the positive direction. And our y value will be +5, because we are going up 5, +5. Alright, so if we look at our graph, we can plot our vertices. So we have -7, -1. There's one point. I'm attempt at a point. Alright, and then we're going to label this with an E, because this is our preimage. Alright, we have F at -4, -4. This is our F. And then we have G at -3, -1. So here is our triangle. our triangle EFG, and it's our pre-image. So now to find our image, we're going to take all the x values and add 2, and all of the y values and add 5. So we'll take this one, our E vertice, and we'll go positive 2, positive 5. So up here is going to be our E prime. Well, we'll attempt to put an E prime. Alright, then we'll take our G, go 2 to the right, up 5. Oh goodness. Alright, and we'll take our F, go 2 to the right, and up 5. This is our F prime, and this is G prime and E prime. So we can connect. So this triangle up here is now our image of our triangle EFG, translated 2 units right and 5 units up. Alright, now we're going to graph the pre-image and image of a square with vertices J 3, 4, K 5, 2, L 7, 4, and M 5, 6. Now this time our translation is written in notation of XY becomes X minus 3, Y minus 4. So X minus 3 is the same as X plus a negative 3. Alright, and then Y plus a negative 4. So if we look at our A and B from our previous slides, we'll know that this is the same as saying translation. We'll say 3 units left because of that negative, because we're going to the negative direction, and 4 units down because again we're going to the negative direction. So if we look at our coordinate grid, we can plot our vertices. So we go 3, 4. And this is our J. We'll go 5, 2. Then I'm going to shoot this computer before it's over. This is our K. We'll go 7, 4. That's our L. And we have 5, 6. That is our M. Connect our dots to get our square. And so now we're going to take each point and we're going to go down 3, or down 4, left 3. So we'll take our J, and this becomes J prime. Take our K, this becomes K prime. Take our L, L prime, and our M. M prime. We can connect our dots to get our nice square back. Now what's important to realize is that the shape does not change at all when we are translating. Nothing changes, our orientation doesn't change, it's still facing the same direction. We're just sliding it left and down. Alright, so we're going horizontal and we're going vertical with our translations. Alright.